Hello everyone, we are engineering statistics students from University of Technology Malaysia. My name is Ha and these are my group members. Previously, we have monitored the production quality of Lajak Kuruih tablet and we would like to present our reports. First and foremost, let's summarize the data that we collected.
The data set shows 200 sample observations taken at random from 3 production shifts run daily, which is morning, evening and night in January 2020. From this table, you can know the weight, percentage of relative density and tensile strength of pill Lajak Kuruih. First is about the weight of the pill. The range weight that the pill produces is between 300 to 390 mg. The histogram shows that the most frequent weight of the pill produced in January 2020 is between 350 to 360 mg. Next is the percentage of the relative density. From the graph, we know that the percentage of relative density of the pill is 85% and above, with the most frequent it produced is 85% to 86%. Another characteristic that we observe is the tensile strength. The most frequent that the tensile strength of the pill produced is 7.1 megapascal. Lastly, we know that the most produced pill is in the morning shift.
Hello everyone, my agenda for today's meeting is to report about production of diet tablet at the factory in January 2020. As already known by all the top management, the Food and Drug Administration FDA authority require that weight of standard tablet produced by manufacturers should be normally distributed with 350 mg with standard deviation of 14 mg. In order to prove our production following the requirement given by FDA, I used the goodness of fit test. The objective from this test is to test a particular probability distribution satisfies or not a population model. The figures show the data that had been summarized. From this data, we will focusing to the range of data that is referring to a category in goodness of fit test and the count of weight that refer to observed frequency. First and foremost, we need to define our claim. I define the null hypothesis is following the normal distribution with mean 350 and standard deviation of 14. For the alternative hypothesis, I define that it will not follow the given normal distribution. With a 5% significant level, we will only rejecting our claim if the value of x squared tests greater than the chi-square distribution. The next step is to find probability value that denote as P and EI value. Take note here that this test is only applicable when the value of EI is greater than 5. If not, we need to combine the data. The figure below show the complex EI value after we combining the data due to EI is less than 5. Value of x squared test could be determined using this formula. From the sample, I obtain the value of x squared test is equal to 1.924. Then we will compare the value of chi-square distribution obtained from the statistical table. From the shown formula, the value of V is 2 and the value of alpha is 0.05. So, I obtain the value of chi-square distribution equal to 5.9915. And alpha is equal to 0.05. We will reject hash note, that is our claim, if x squared test is greater than 5.9915. Thus, we will fail to reject hash note and conclude that there is no evidence to support the weight of Lajak Kuruih that diet tablet do not follow the normal distribution with a mean of 350 mg and standard deviation of 40 mg. We now have a significant evidence that show this diet tablet following the distribution required by the Food and Drug Administration FDA authority. That's all from me. Thank you.
Okay, Assalamualaikum. So for this meeting, me, Adam Syed, going to present about is there any significant difference between the tablets for Lajak Kuruih F in the different shift.
So for this meeting, for my part, I will explain whether there is significant difference in between tablet weights from different shift or not. Okay, for Lajak Kuruih F, we have about a total of 200 pills for all the shifts. So to know is there any difference, we can use ANOVA or analysis variance. This method is used if there is 3 or more than 3 population means in the data. So we have 3 shifts. So ANOVA is the best and the suitable method that we can use to know the difference. So from this table, first of all, I will make the pivot table using the Excel, and I got this table. So from this table, I group every data into this table according to the shift, morning, evening, and night. So after I grouping all the data, I use the table to make the data analysis and using the ANOVA single factor. So after I got the ANOVA single factor, I forgot, we need to set the null hypothesis, which is mu1 equal to mu2 equal to mu3. Mu1 same with morning, mu2 we assume to evening, and mu3 we assume to the night. And the alternative hypothesis, at least one of the mu is not same. So after that, we got this table which show the sum of square, degree of freedom, mean square, F distribution, and p value. So to get the F value, we can use the formula of the mean square for the between the groups divided with within the groups value. So we got this value. So using this F value, we got the P value, which is 0.120043. And we compare with the value of alpha, which is 0.05. So we got that the P value is greater than the alpha value. Thus, we accept the null hypothesis, which is mu1 equal to mu2 equal to mu3. So in the conclusion, there is no significant difference between the tablet weights from the different shifts. Okay, thank you.
Assalamualaikum and good day everyone. Today I'm going to explain about the regression summary output. Okay, let's move to the first table. Alright, multiple R. The first one is multiple R. Multiple R is actually the correlation coefficient, and the value is obtained by taking the square root of R squared. So square root of this value will give us the multiple R. R squared is actually the coefficient of determination, and it is used to check the adequacy of a regression model. And this observation is actually the number of sample data. So here we have 200 data. So let's move to the ANOVA. Okay, the first column shows us the degrees of freedom for the three variables here. The next is sum square, and this is mean square. The value of mean square is taken by simply dividing the sum square and the degrees of freedom. For example, for the mean square of regression, we take 5.37463 divide by 1 and we got this. Same goes to the residual mean square. The next column is the value of F. The value of S is the value of test statistic, whereas the significant F is actually the probability of F being more than the test statistic. So here, we can make a decision by comparing the significant F with the significant level alpha. In this case, our alpha is 0.05, and this shows that the significant F is less than alpha. Thus, we have to reject hash note and conclude that beta is not equal to 0, which implies that the linearity between the two variables does exist. This graph clearly shows us that the existence of linearity in the regression model, as we can see the red line of prediction tensile strength. So, I want to highlight here that we don't have to worry because our production is running smoothly based on this data obtained. That's all from me. Thank you.
Alright, now let's do a quick recap.
After monitoring the production, we verified that the weights of the Lajak Kuruih tablet do follow the normal distribution with mean of 350 mg and standard deviation of 14 mg. On the other hand, there is no significant difference between the tablets produced during the 3 different shifts. Then, when the relative density values of the tablets are 68%, 74.3% and 80.1%, their predicted tensile strengths are 5.58 megapascal, 6.07 megapascal and 6.53 megapascals respectively.
Alright, that's it. That is all from us. Thanks for watching.